Hello all. Today's video is with respect to the SDV mindset. The reason, so there is a backstory behind shooting of this video because lately I have been getting messages from many people asking me that what are all the set of technologies which they have to learn so that they can contribute in a good way in this SDV revolution which is coming up in the automotive space. So when I got this question from couple of people, then I thought that okay, fine, this could be the general conception with respect to what SDB is, and let me just make a video with respect to what exactly is it. Like, is SDB a piece of technology or is it a mindset? So because of that reason only, I am just shooting this video. So lately, if at all any one of you guys you remember, before 2007 there used to be multiple phones, and the innovation with respect to the OEMs, say Nokia or BlackBerry back then, was with respect to the uh, specific segment of people whom they are targeting. So if at all you see this particular Nokia Engage phone, me, I was a teenager back then. I really wanted this phone because this phone was very specific with respect to gaming. So this phone, the feel, the look, everything, the keyboard and everything was with respect to gaming. Similarly, BlackBerry had their own phone which used to appeal for the business people. So similarly, there are many different styles of phones which used to be existed way back in 2007 before the introduction of iPhone. So this was the kind of technology and innovation how the phone companies used to think about. They used to think that this is how the innovation is actually all about. Then came the iPhone moment, which actually changed everything. So that started the smartphone revolution. But if you see a transition of this kind of, if from this kind of a phone to this kind of a phone, was not because of a what to say, a programming language or maybe a chipset or anything like that. So if at all you see, it is not some programming language which has actually led to the creation of the iPhone, but it is actually the fundamental shift in the or the new mindset change which has actually brought the software revolution in. So I'll explain you how prominent that is and what actually led to it. So way back in 2007, before 2007, all these technologies were already existing. So there was this capacitive touchscreen existing from a company by name Fingerworks. They were kind of pioneers, which was procured by, acquired by Apple before the iPhone was released. There used to be a phone which was like people were addicted to. People used to play games in it, but the software over there was not flexible. And everyone knows the iPod, the music device which basically kind of revived the Apple brand as such, which kind of ate away the market share of the cassette based music players, the Walkmans, which revolutionized it. So and Apple used to have the iOS which used to power their iMacs, and there used to be a decent amount of connectivity also. So what Steve Jobs envisioned back then was to merge all these existing technologies such that you can basically create a phone out of it. So iPhone in a way cannibalized the iPod sales, but the transition was necessary. So if at all you look at the early 2007 iPhone launch, the event, then you will actually know that so it is with respect to, there was a famous quote which used to say that we are merging three technologies. One is an iPod, a phone, and a internet navigator. So he is speaking about the connectivity, the phone usage, the fundamental phone usage, and uh, iPod like feel of listening to a song and all. So what actually Apple did back then was they saw different set of technologies which are actually out there, and they have merged these technologies together to create a phone. That is what they did. It is not maybe a programming language, or it is not some a piece of a technology which actually led to the revolution, but the way they have perceived the phone, the fundamental difference, that actually made all the difference, and that kick-started the smartphone revolution. and later on many people contributed, and that led to lot of what to say yeah, now we know the lot of applications which were built on top of it, the existing technologies which are I mean like the existing data or whatever, these sensors which are actually out there, say GPS. A GPS which comes with a smartphone is actually enabling Uber to create an application out of it so that you can summon a car. Similarly, the same GPS or whatever can help you to get the groceries delivered to your place. The camera inside the phone is enabling Instagram. Similarly, the video sharing of applications by watching a video or a movie and doing payments, playing a games using the sensors which are out there in the phone. So this is how a simple smartphone uh, which had some set of sensors have been leveraged by third party developers to create useful applications which we use on day to day basis. And we can, and now if we go back to those primitive days, we can kind of laugh about how the companies used to think back then, but this is how it is now, but that was not the case back then. So that actually led to the downfall of Nokia. Anyways, coming to the current scenario with respect to automotive space. So automotive sector as such has seen a lot of revolution with respect to having a being a pure mechanical system, from there being an electromechanical system, then having the microcontrollers in, then slightly having more advanced computers for ADAS use cases and all. And so as we can see that the automotive industry also has seen its own set of evolution over a period of 100 plus years. And now the mindset which I am talking about is that right now automotive sector is in a place where they are slowly moving towards electrification. So once you move towards electrification, you have less moving parts, you are coming to a zonal architecture which makes life easy. And there are strong cloud providers who can actually create who can actually consume the data which is being generated by these cars, and organize it in such a way that you can actually make it a digital twin out of the car, on which you can do your testings. You have high performance computers inside the car, you have artificial intelligence which is becoming more and more sophisticated, and using less amount of resources as possible and efficiently delivering the results. You have the organizations which are standardizing most of the stuff so that there could be a lot of interoperability across the OEMs, tier 1, tier 2 suppliers and everyone. And you have the high speed internet accessibility so that everything is connected, which can enable the V2X scenarios. So with these technologies in place, what is actually going to happen now is the SDV is not a set of a technology. Once you learn, you will be SDV ready. It is the fundamental mindset which is actually changing how the OEMs, how the tier ones, and how the suppliers and other people, other stakeholders, and other non-automotive stakeholders like the cloud providers and everyone, they are looking at the automotive space as such. So this will lead to a lot of disruptions which will be going on in the current automotive use case. That could be with respect to the CI/CD, that could be with respect to learning of some of the cloud technology, because the existing the cloud connectivity with respect to the vehicle is restricted only for the OTA most of the use cases, which might not be the case. So you may have to have some kind of cloud expertise when you are kind of preparing a use case for it. The earlier the releases, the rate at which any an issue is being diagnosed or detected will change, because now you will have a continuous feedback of the failures coming in, that too from a fleet of cars or from lot of cars which will be available, which will be pushing for a faster improvement rate. You will have artificial intelligence out there doing its own piece of work. You will have containers. You will be having new programming languages like Rust, which are much more secure than compared to the traditional. See, you have the like even at the hardware level you have Ethernet based communication system, so that the data rates are faster, and also having this set of technologies, I mean like this set of disruptions, independent disruptions are will lead to a push in the direction where the developer may not be expected to have only one set of a skill, but he will be expected to have multiple set of skills, not just one. So that will eventually happen, but it is not like you learn Rust and you are SDV ready kind of a thing, or you run cloud and you are SDV ready kind of a thing. So disruption happen at every level, and the legacy systems like AutoSAR and everything will definitely stay for sure. QNX will definitely stay for sure. So they are not going to be replaced, but they will be augmented with other new technologies down the line. For that, flexibility is needed with respect to the developer. So the earlier the slow process of software development or slow process of moving from one technology to another technology, which was the case in automotive, might not work going forward, because you need to react at a much more faster pace, maybe like a cheetah. Maybe that's the way forward. That is how I feel that the systems might move forward. So so almost the uh, summary of the video is that there are disruptions going to happen at every vertical in the automotive space, and whatever technologies which you already know will not be replaced just like that, but some additional technologies will be added on top of it. So that depends on what technology you are working. So extending your skill set in that particular domain wherever you are can actually make you SDV ready kind of a thing, rather than that depending on just simply on one technology. Learn this and yeah, that will do the job for everything. So that is not the case, which has been clearly demonstrated during the smartphone revolution. So this is the end of the video. Thank you. Thanks a lot for your time.